Alright, so let's talk derivatives. In this box we have what is the definition of a derivative. So the idea is that the derivative at a number a, which is an x-coordinate. Okay, so f prime of a, that's how you say that, f prime of a is the derivative of the function at a, is equal to, and this should look familiar, the limit as h approaches 0 of f of a plus h minus f of a all over h. So this is the formula that we use when dealing with tangent lines. So what we are looking at is we are simply going to take the function and we are going to find the derivative using this limit definition. Okay, so we have a function x squared minus 8x plus 9. I want to find the derivative of that function at some number a. So f prime of a is going to equal the limit as h approaches 0 of, now on top here we're doing f of a plus h, right? So what this means is that every single place that we have an x in the function, we're going to replace it with a plus h. So we're going to do a plus h squared minus 8 times a plus h plus 9. That is all f of a plus h. Then we're going to do minus f of a. And so f of a would say, well, just replace all your x's with a's. A squared minus 8a plus 9. Now notice how I put that in parentheses. I would encourage you to do that, because if you do not do that, you will forget to subtract that entire function, which means you'll forget to distribute this negative, and things will come out incorrectly. So make sure that when you subtract f of a, you subtract the entire function f of a by putting that in parentheses so that you can distribute that negative. And this is all over h. Now again, evaluating limits, what I'm trying to do here is plug in 0 for h, but I can't do that because of this h on the bottom. It's really easy to know when you can evaluate your limit, because you have to get rid of this h on the bottom. There's no way around it. Like I've got to get rid of h, because I can't plug in 0 until I get rid of that thing. So all you have to do at this point, say all you have to do, it's going to be quite a bit of work here, but what you have to do is multiply out, distribute, simplify the top as much as you can, and then we are going to be able to cancel some things, and we should then be able to evaluate our limit. So this can be done in as many or as few steps as it takes to evaluate all of this, so it depends on how good you are at algebra. A plus h squared. When I do a plus h squared, that is a squared plus 2ah plus h squared. I'm going to distribute my negative 8, so minus 8a minus 8h plus 9. Then I'm going to distribute my negative here, minus a squared plus 8a minus 9, and that is all over h. So I was able to completely multiply out the top in one step. You should be able to do that. I think the only thing that might take you a little bit of time here is to do the a plus h squared. Just remember that that means a plus h times itself, and multiply that out, and combining like terms, you would get this. If you can remember that a plus h squared becomes this, it will save you a lot of time. The next step is this. Once you have everything multiplied out, you should be able to look at the top, and everything that does not have an h should cancel. If it does not, you did something wrong. So a squared minus a squared, those cancel. Minus 8a plus 8a plus 9 minus 9. Okay, so all of those things cancel. So at that point, what we have left is the limit as h approaches 0 of 2ah plus h squared minus 8h all over h. Since every term has an h, I can now eliminate an h from every term with the h on the bottom, giving us the limit as h approaches 0 of simply just 2a plus h minus 8. I can then plug in 0 for h, and I end up with 2a minus 8. Now, sometimes this may simplify down to just a single number. Sometimes you may have some kind of expression here with a's, and that is okay. What we're saying is, whatever the x-coordinate is, we are just calling this generic x-coordinate a. Whatever that x-coordinate is, if I want to know the derivative at that x-coordinate, and again, that's going to tell me the slope of the tangent line at that x-coordinate, it's simply going to be found using this 2a minus 8. Okay? So instead of having to go through and plot that point and then try to figure out what the slope is by taking another point and making that really close. So we did this last unit by making tables and making that second point get really, really close. What we're saying here is if I want to know the derivative, the value of the derivative at any x-coordinate, if I just make that x-coordinate a and I go through this process, I can then find the slope of the tangent line, which is the same as the derivative, at that x value that we are calling a. So if I wanted to know, hey, what is the derivative at 1? What is f prime of 1? All I need to do is plug in 1 here, and I would get negative 6. So the slope of the tangent line to this function at an x-coordinate of 1 is negative 6. At 2, it's negative 4. Right? So I could keep plugging things in here. At 4, it's going to be 0. Right? So I could use this expression now to figure those things out instead of actually plugging a number in here. Okay?